We're going to move on to 6.7 today, and I think most of what's in there you could probably figure out on your own, but I'll help you out a little bit. So in your books, turn to page 386. On this page, we're going to talk about the lengths of sides and the size of angles. And this uses something called the hinge theorem. So the hinge theorem, if you look at this first set of triangles right here, we have two triangles that have two corresponding sides. What that means is this side and this side are the same size. Okay. And then this side and this side are the same size. And the hinge theorem says if two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second. Now that's a really wordy way to say that this length is bigger than this length. Why would that be? How do we know that that one is larger than the other? The angle's bigger, right? And one way I would look at it is, if we were to pick this triangle up and set it in here, then this side right there would match up with this side, but the angle is smaller. So the second side, this one right here, is going to be something like that. And then when you connect the last side, this side right here would only be that long, and you can see that XW is longer than that. Does everybody understand that? A triangle that is more open has a third side that's larger than the other. Does that make sense? Okay. And then down below you have the converse, which basically says if you know what the side lengths are, then you can determine the angle. So this is equal to this, and this is equal to this. And then I have the third side of the first one is 12, and the third side of the second one is 9. So this says the measure of angle C is larger than the measure of angle F. Why is that? How do we know that's true? What is it about the triangle that tells me that this angle is bigger than that angle? The length of the side. So once again, if I take this side, it will perfectly match up right there. Okay? And then that 9, this right here is only 9. So if I go up 9, then you can see that this angle is smaller than that angle. Okay. So let's look at this one. So we can only use the hinge theorem when we know that two sides correspond. Do I have two sets of equal sides in this triangle? Well, I have this one matches that one. Do I have another side that's equal? Which one? Which one? Oh, what did I do? Sorry. Okay. The ones that are the same, right? This one is equal to itself. Okay. So in this first triangle, we're going to be talking about that angle. In the second triangle, we're going to be talking about this angle. So we have the angle TSP, and we want to know how does it compare to angle RPS. So we have three choices. We can either say less than, equal to, or greater than. How does TSP compare to RPS? TSP has to be bigger. Why? It's opposite the larger side. 24 is bigger than 23. So if I match those sides with the angle, this side matches up with that angle, and it's 24, and this side matches up with that angle, and it's 23. So the answer would be greater than. Okay, look on the next page. And we have 2 here. Okay. So the third side is right there. We want to compare the size of JM to ML. Is JM bigger, smaller, or equal to ML? JM has to be larger. 64 is bigger than 61, so we would put greater than. Okay. Down in the next one, so we have these angles are equal. And I can't see it, but it says if PR is equal to PS, which we have marked, and QPR is bigger than QPS. So it says the measure of QPR, PR is larger than QPS, then which one's bigger, SQ or RQ? QPR is larger than QPS, so is SQ or RQ bigger? So look here, QPR, so this angle right there, is bigger than this angle, so which side is bigger? RQ has got to be bigger. If this angle is bigger, then that side is bigger. Okay? We're not going to do proofs, proving triangle relations. All right, solving a real world problem. Turn the page. Two groups of bikers leave the same camp heading in opposite directions. Each group travels 2 miles, then changes direction and travels 1.2 miles. Group A starts due east and turns 45 degrees towards the north. So this guy is traveling this direction and he turns that direction. Group B starts due west and then turns 30 degrees towards south. Which group is further from camp? Explain your reasoning. So one guy is traveling due east and turns and goes this direction. Okay. Two groups of bikers leave the same camp heading in opposite directions. So the other guy, oh, I can only see half of it, huh? So the other guy is traveling this direction, and then he makes a 30-degree turn. So he makes a turn, let me move these over a bit. That looks like this. And then this angle is 45, and this angle is 30. Now we want to know who is further from camp. Okay? So we know that this is 2 miles and this is 2 miles. What else do we know? Then this is, what was the number on that? 1.2? 1.2. So this is 1.2 and this is 1.2. Okay? So we basically have two triangles. This matches this, and this matches this. And we want to know, is this group longer? Is that distance longer? Or is this distance longer? Well, we have to look at the angles. What would this angle be? 150. And what would this angle be? 135. So, is the right one longer or is the left one longer? The left one is longer because the angle is bigger. This angle is larger, which means this person is further away from camp. All right? So, your assignment. So, we're going to do 3 through 10. Let me write this down. So, this is 6.7, 3 through 10 all. And then 13 through 17 all. All right. Get to work.